This is the video supplement for your Polarity in-class assignment. What I have here is a video of all the different shapes that you will see in your class, and it's your job to answer all those questions on a separate sheet of paper. So for each shape you see, and there'll be 11 shapes, you'll have to give the geometry, you'll have to determine if the shape is symmetric, and then you're going to determine if the molecule is polar. Once you do that, the whole goal of the assignment is for you to come up with a pattern that you see based on the structure of the molecule. So based on those that you see that are polar and those that aren't, can you determine a pattern? Now the pattern should be checked until you get something that makes sense and applies to everything, or most everything. Okay, let's just start. So this is shape 1 here. It looks like this. Notice that it's got a double bond here, and this applies for all the shapes, that you'll assume that there is no, or that all the bonds are polar. When you're trying to determine if the molecule is polar, you're going to assume that all the bonds are polar. That way you're only focused on one thing. You don't have to worry about electronegativity differences in this case. So this is your first one. You're going to determine what the shape is, and you're going to determine if it's symmetric, and if it is symmetric or not symmetric, and then you're going to tell me if it's polar. So this is the first shape. Now for shape 2 here, and you may want to pause these as I'm flipping them around so that you get a chance to look. But again, remember, you're assuming that the bonds have an electronegativity difference, and for something like this, that paddle that you see up there on the top of your inset, that paddle represents an unshared pair or non-bonding pair of electrons. So if I were to help you out on this one, I would say that this has 4 electron domains, and 3 of them are bonding. Okay, so that helps you out. Now again, you can pause this and look at it as I'm maneuvering it around, and look at it as many times as you want. But that's the shape. Shape 3 is right here. You can see, I can flip it around and you can look at it. This number up here in this corner, that's just telling you which problem we are on. Okay, that way we're good. Okay, so there's the shape. Flip it around. Okay. Problem 4 here, you can see, looks like this. Okay, so it's got 2 lone pairs of electrons. Okay. So there's the 5th shape. Okay, let me maneuver it around here. Okay, so you can see what this looks like. Again, feel free to pause and remember that you're assuming every bond is polar or has an electronegativity difference. Here's the 6th shape, number 6. Okay. Oh, can't do that very well. My hand's in the way. Okay. Here's shape number 7. Okay. Let's look at it. We can see, make sure I can hold this thing, right? Like, look how I'm manipulating it. Let's see. Okay. Whoop. Make sure so here's shape 8. Let me see. So that's what it looks like. Do that and that. I'm just trying to move these shapes so that you can get a really good view of what they look like as we manipulate them. Okay, go like this. Maybe spin it a little bit. Okay, woo. Okay, and so here's shape 9. Okay, you get a good look at this. Maybe I'll see if I can move my hand. Oh, it's hard to do stuff with. Okay, shape 9. Let's see what I can do here. And here's shape 10. Okay, just so you know, I've already double checked these. None of them are the same. Okay, shape 10. Okay. Here's shape 11. Woo! 11. Make it look really good. I don't know how I can do much more with this. Let it roll around. Okay, and so now here are the challenge problems. Now these challenge problems should be taken separate from the patterns that you're looking at. You should only use the first 11 molecules to determine the pattern. So in this case, this is a challenge molecule. I just wanted to see this shape, and then you can tell me if it's polar, not polar, symmetric, all that stuff. But keep it out of your description when you're doing this. I don't know exactly how to. Woo! Okay, let's see. So we do that. Okay. And here's the last challenge problem. There's the second one. So there's only two. But again, keep this out of your description of whether of the pattern that you see, because these things are special. So again, the paddles represent unbonded electrons. So you can see how this is all going together and working. Okay. So, woo. Okay. So there you go. Write it all down. See if you can come up with a pattern and have it checked with me. Thanks.